So in this video, let's get a little review of our linear functions. So a form that we most often use is the slope-intercept form. So it's where you can see a value for the slope and a value for the y-intercept. So our function would be mx plus b, where m is the slope of the line, or you could think of that as our rate of change. And then b would represent our y-intercept, to be given as this f of 0. So we have this point 0b on our graph, and b would be where we're crossing the y-axis. That would be our y-intercept. So finding the y-intercept is pretty clear on a graph. We have the graph of a line, then our y-intercept would be this point where we cross the y-axis. The slope can be slightly trickier. What we want to do is in the numerator of slope, look at the change in y, the change in outputs, over the change in inputs. So this is how we see it in our function notation. We have the output of b minus output of a, and then we put that over the difference between those input values of b minus a. How you've probably seen this before, before we had function notation, is if we had 2 points, x1, y1, and x2, y2. Then slope would be the difference of the y values over difference in the x values. And that's the same exact thing that we're doing here. It's just with function notation. Another way that we can express a line is with point-slope form. So from the name, as you can imagine, when we see this form, you can see a point, a coordinate, as well as the slope. So we have this f of x minus f of a, so this is going to be an output from a coordinate that we have, equals, and then we have our slope m, times, and in parentheses, x minus a, where a would be our value for, the x value for that point. So let's just kind of play around with these ideas where we're given some information, and we're just going to fill in the blanks in terms of what's the equation of the line, and we can use point slope or slope intercept. Usually one's easier than the other based on the information we have. And then from there we can find these different values, the slope, y-intercept, and then just another point on the graph. So with this first one, we're given the equation of a line. What I can notice here is that this is in point slope form, the key being that something's adding on with the f of x value. So if I want the slope is going to be what's multiplying with the parentheses. So I have m equals, and that positive 1/2. Now I'm going to save the y-intercept for a second, because if we have point slope form, then I can see a point coming through. So the point that's coming through in terms of location is this positive 1/2 and this minus 1. Now when we use point slope form, we have to be super careful. Something we want to think about is that this is expected to be subtraction between those output values, and this is expected to be subtraction between the input values. So we expect subtraction to be there. So how I actually want to think about this, I know this is kind of strange to write it this way, but if I expect subtraction to be there, then for my output to have a positive 1/2, I technically have a negative 1/2 there. See how we have subtraction of a negative, so that would make the positive, but I just need that subtraction symbol so that it can match the form up above. And then I have equals 1/2 x, and then because that's subtraction there, that's working great. I have subtraction of a positive 1. So when I go to fill in the blank for this specific point on the graph, I have this negative 1/2 for my output value, and then my input, I don't include the negative because I want that subtraction to be there next to x. So when I grab 1, I'm going to grab a positive 1. So my point would be negative 1/2. Nope, that's the y value. Positive 1, negative 1/2 for the output. And if you get to that point and you're very unsure if that's correct, just plug it in and see if it works in the original equation. So if I plug in x equals 1 and plug in negative 1/2 for f of x, does it all balance out? Okay, with the y-intercept, what we want to do is plug in x equals 0 and solve. So I left myself a teeny tiny bit of room here. I want to look at f of 0. I basically want to solve for f of 0. I have that plus 1/2 and then equals 1/2, and then x is going to equal 0 minus 1. And I'm going to simplify. So this is going to be, I'm going to simplify that right-hand side first. So 1/2 times a negative 1, so that's negative 1/2. And then I'm going to subtract 1/2 from both sides. So that's going to give me f of 0 equals negative 1/2 minus 1/2. Should be a negative 1. So my y-intercept is x is 0, and the output would be negative 1. So that's how we can fill in the different pieces if we're given point slope. In this next one, we're given the slope and we're given the y-intercept. So I'm going to go ahead and start with the equation part because I can easily write out the slope-intercept form. So f of x equals, and I'm going to take my slope of 2/3 and then times x, and then our y-intercept is a positive 4/3, so plus 4/3. And that's our equation. Now to find a specific point, all we need to do is just plug in some value for x. I'm just going to go ahead and plug in x equals 1. No real specific reason why. You could choose any value for x except for 0, because that would just give you the same y-intercept point. Anything besides 0, we can plug in here. So what this will look like is 2/3 times 1 plus 4/3. So that's a 2/3 plus 4/3. So luckily they have the same denominator, so I can just add my numerators, which is 6, over that common denominator of 3. I'm getting a value of 2 out. So what this tells me is that when x is 1, my output is 2 at that coordinate. Alright, our next one, we're given the point and slope. So I'm going to start with my equation and put in point slope form, since that's the information we have. So my form goes f of x minus, and then I want to use the output of that specific point that they give us. So the output is the 0. So I'm going f of x minus 0 equals, and then my slope times, and then x minus, and then the x coordinate from this specific point, which would be 5. So just to simplify this a little, well, we could leave it actually just like this. This really shows the point slope form. You could simplify this if you want to, if you didn't want to necessarily see it that way. It would be negative x minus 5. And you know, then we're just one step away from slope-intercept. So let's even go one step further, because then I can see what my y-intercept is and I can answer that question. So when you have point slope form, I always think of it as kind of messy. It's not necessarily messy, it's just not simplified. So if you take point slope form and simplify it, you're going to end up with your slope-intercept form. So for my intercept, we have a positive 5. That means we have x is 0, and the output is positive 5. Okay, this last one here, kind of the same idea as what we just did, in that I'm going to start with point-slope form, because I'm given a point and the slope. So we're going to have f of x minus, and the output is negative 1, I'm going to have negative 1 in parentheses there, equals, we have a slope of 0, it's kind of special, and then x plus, or let's go, I'm going to show you it all written out, x minus, and then the negative 7 for the x coordinate. So what this comes down to is f of x, and this is plus 1, equals, and 0 times this x plus 7, but since that's all being multiplied by 0, we would just have a 0 there. When we have a slope of 0, this is graphing a horizontal line. There's no slope. So what's going to end up happening, if I move that 1 over, this is giving me f of x equals negative 1. What this is making is a horizontal line along negative 1. So we have all of these outputs of negative 1 for absolutely any x value. So what that would mean for our y-intercept is that no matter what, our output is going to be negative 1. So that's going to be 0, negative 1. Alright, so that's how we can work with a few different forms of our linear function and thinking about slope and intercept.